Zane Reborn II, YouTuber, lover of dinosaurs, maker of Maddie, creator of Kamikaze, and now inventor of the Flying Hammer. Today I challenge Zane Reborn Flying Hammer with a bat.
No. I'm sorry, what?
Bats have long fascinated humankind. They're the only mammals capable of sustained flight, evolving delicate wings that balance the force of gravity with the need for speed and agility. Beyond their remarkable flight, bats boast advanced echolocation systems that allow them to see through sound, navigate the darkest nights, and track prey with astonishing precision. The next question is, how do I create a giant bat? Part 1. The Indian Flying Fox. Choosing the Indian Flying Fox as our genomic anchor was a strategic move. Its natural design maximizes the balance between lift and agility. Imagine scaling up these traits, enhancing them further to support increased weight while preserving the elegance of flight. The base genome is the canvas where we add layers of extraordinary features in our hybrid experiment. Part 2. Big Brown Bat. When it comes to design, beauty isn't just skin, it's in the details. The Big Brown Bat offers an aesthetically pleasing package, gentle curves, balanced proportions, and an undeniable warmth in its gaze. This charming profile gives our hybrid creature not only marketable appeal, but also an emotional connection that draws viewers in. Why select the DNA of the cutest bat rather than using genes from less photogenic, deformed bats? In genetic design, every trait contributes to a creature's overall value, not just in survival, but in visual impact. In our hybrid blueprint, every trait must serve a dual purpose: practical ability and aesthetic appeal. The Big Brown Bat's DNA is a prime candidate because it refines our creature's look. It softens the otherwise rugged structural aspects of a giant bat. Part 3. Lesser short-nosed fruit bat. We're turning the dial on adorable. Why settle for a standard bat when you can design one that's twice as cute? Introducing the lesser short-nosed fruit bat, nature's blueprint for charm. With its endearing facial features and a look that practically beams personality, this species is our secret ingredient for pure, unadulated cuteness. Part 4. Vampire Bat. Vampire bats are not your typical nocturnal flyers. They've evolved a unique survival tool, saliva that contains specialized anticoagulant compounds. This remarkable trait prevents blood from clotting, ensuring a smooth, continuous flow when they feed, and it's a trait we decided to incorporate into our giant hybrid bat design. Bats have mastered the art of keeping blood in a flowing state. Part 5. Greater Horseshoe Bat. In our quest to design the ultimate giant hybrid bat, we've incorporated these game-changing echolocation genes. By borrowing directly from the Greater Horseshoe Bat, our hybrid gains a state-of-the-art sonar system, allowing it not only to survive, but to thrive in all environments, whether cloaked in darkness or amidst urban chaos. Part 6. Bottlenose Dolphins. Bottlenose dolphins are renowned for their highly developed echolocation system. Unlike many terrestrial animals, these aquatic marvels deploy rapid high-frequency clicks and listen for the returning echoes to construct an intricate 3D map of their surroundings, even in complete darkness. Their refinement in sound production and interpretation makes them one of nature's most sophisticated sonar specialists. So, why integrate a dolphin's echolocation with our bat's genetic framework? While bats already boast impressive sonar systems, dolphins deliver an added layer of precision and multi-dimensional mapping. By borrowing traits from the bottlenose dolphin, our hybrid not only inherits the timeless ability to navigate by sound, but also gains enhanced signal refinement and processing. This could potentially allow our bat to operate more effectively across varying environments. Part 7. Orca. Orca are among nature's giants. Known for their impressive size and strength, these marine mammals dominate the ocean with their powerful presence. But it's not just their size that amazes us. They're also masterful communicators. Equipped with a sophisticated system of clicks and whistles, orcas utilize a form of echolocation that rivals even the most advanced bat sonar systems. With the orca's genetic boost, our hybrid bat isn't just a scaled-up version of its smaller relatives. It becomes a supercharged marvel. The enhanced size provides increased stamina and payload capacity, while the refined echolocation offers a panoramic sensory world. This dual upgrade means our bat can traverse thorny urban landscapes as effortlessly as it soars through natural wilderness. Part 8. Northern Short-tailed. Certain species, like our northern short-tailed inspiration, have evolved an extraordinary trait: teeth that are reinforced with iron. This isn't a trick of the light. Nature has equipped them with a system that deposits iron compounds into their dental structure, boosting durability and ensuring a razor-sharp bite. Here's how it works. During tooth development, specific genetic signals guide the process of biomineralization. In the northern short-tail, these signals trigger the deposition of iron phosphates within the enamel. The result? Teeth that are not only tougher but also more resistant to wear and tear. A true natural forging process that gives them an edge in the wild. Part 9. The Tasmanian Devils. Tasmanian devils may be small in size, but they pack a serious punch. Their unusually sharp teeth and robust jaw muscles give them one of the strongest bite forces relative to body size in the animal kingdom. These features evolved to help them crush bones and tear through tough meat, traits that are essential for survival in the wild. Part 10. The Tarsiers. Tarsiers are fascinating creatures. Despite their diminutive size, they possess some of the most remarkable eyes in the animal kingdom. With eyes almost as large as their brains, tarsiers dominate the night with unparalleled visual acuity. Their evolutionary journey has honed their ability to thrive when light is scarce, making them the perfect model for augmenting the sensory prowess of our hybrid bat. Part 11. The Cheetahs. Cheetahs are synonymous with explosive speed and precision. What many don't realize is that their vision is perfectly engineered to support these high-speed chases. Their eyes are adapted to quickly process rapid movements and maintain sharp focus even in the harsh glare of bright daylight. This ability to track fast-moving objects and perceive rapid details is what we are harnessing for our hybrid. Part 12. The Reindeers. Reindeer, the stalwarts of the Arctic, aren't just built for survival in bone-chilling temperatures. They're also equipped with a unique visual superpower. Unlike humans, reindeer can perceive ultraviolet light. This adaptation allows them to discern contrasts in the snowy landscape, such as the patterns of lichens or subtle changes in their surroundings that remain invisible to the human eye. Reindeer eyes are specially tuned to detect ultraviolet wavelengths. Their retinal cells are adapted with a high density of UV-sensitive opsins, which, combined with a reflective structure, allow them to capture even the faintest UV signals. This evolutionary tweak gives reindeer a distinct advantage, illuminating a hidden world where snow and ice reveal patterns and contrasts that most creatures, including us, simply cannot see. Part 13. Bloodhounds. Bloodhounds are legendary when it comes to scent. With up to 300 million olfactory receptors compared to our mere 5 to 6 million, they can detect and differentiate even the faintest trace odors from miles away. It's this supercharged sense of smell that has made them indispensable in search and rescue, tracking, and even forensic investigations. Part 14. Rhesus macaques. Rhesus macaques are renowned for their trichromatic vision, an ability to see a full spectrum of colors just like humans, but with nuances that are uniquely their own. Their eyes are exquisitely designed to pick up subtle variations in red, green, and blue, providing them with a rich, detailed view of their world. This superior color perception is what makes them such a vital inspiration for our project. Part 15. Howler monkeys. Howler monkeys live in a world alive with color. Their visual system is finely tuned to pick up subtle differences in hue and brightness, allowing them to navigate their vivid habitat with astonishing precision. In nature, this heightened color vision means spotting ripe fruit among dense foliage or effortlessly distinguishing between similar shades, a capability that's nearly double what you'd find in a typical mammalian eye. Part 16. Chimpanzees and Great Ape. Chimpanzees and their ape cousins are renowned for their advanced problem-solving skills, complex social structures, and remarkable memory. Their brains afford them the ability to learn, innovate, and even use tools, a cognitive edge that has long fascinated scientists and inspired new frontiers in bioengineering. Part 17. Prairie voles. Prairie voles are renowned among rodents for their monogamous behavior, forming enduring pair bonds that last a lifetime. Unlike many animals whose mating strategies are fleeting, these voles stick by their partners through thick and thin, creating a stable family unit that supports cooperative rearing of offspring. Why do prairie voles mate for life? It all comes down to their neurochemistry. Elevated levels of oxytocin and vasopressin in their brains promote social bonding, trust, and the formation of long-lasting partnerships. This natural predisposition toward monogamy not only ensures cooperative parenting, but also fosters a stable social environment. It's a living lesson in loyalty and mutual support. Part 18. New Zealand White Rabbits. New Zealand white rabbits are known across the world for their impressive reproductive rates. These animals can give birth to large litters several times a year, ensuring a swift turnover and robust populations. Their rapid breeding is nature's way of keeping their numbers high and resilient in the face of challenges. Part 19. Introduction. Scientific name: Gigans. Ingenium chiroptera. Common dictionary name: giant-witted bat. Nickname: Conroy. Female. Counterpart: Grace. Height: 3 feet. Length: 6 feet. Weight: 150 pounds. Wingspan: 20 feet. Physical characteristics: our hybrid is a seamless fusion of nature's best. It carries the robust skeletal framework of the Indian flying fox, the charming features of the big brown bat and lesser short-nosed fruit bat, and the reinforced iron-infused bite of our inspired predators. Its wings, powerful and yet delicate, allow for effortless, dynamic flight. And those eyes, engineered to harness both ultraviolet and vivid trichromatic color vision. Behavioral traits: this creature is as fascinating as it is formidable. Enhanced with the intellectual firepower of chimpanzees and great apes, it's not only smart, it's capable of dynamic problem solving and even refined social interactions. With a nocturnal mindset, it employs a state-of-the-art echolocation system bolstered by marine and bat sonar genes to navigate, hunt, and interact with unmatched precision. Speed. Of flying in the air. Top burst speed about 75-80 empatherma birds, rivaling high-performance birds like the swift. Cruising speed, a steady 40-50 empath, allowing efficient long-distance travel without fatigue. Acceleration, going from a stationary hover to 50 empath in roughly 3-4 seconds, giving it incredible maneuverability during hunting or evasion. To put it in perspective, a Tasmanian devil averages 155 psi, a big dog around 350 psi, and a hyena peaks near 1,100 psi. Our hybrid 600 psi bite force positions it above wolves and big cats, making its jaws among the most powerful in the animal kingdom. Our bat's 0.1 MeV/kg positions it among the world's deadliest natural toxins. Coupled with flight, echolocation, and razor-sharp teeth, by uniting the best of nature's visual adaptations, our creation doesn't just see, it perceives. Its eyes transform every environment into a high-defection tapestry of light and color, making it a true master of the dark and the dazzling. Whether tracking prey in near-solar darkness or navigating vibrant urban landscapes, the giant hybrid bat's super eyesight sets a new benchmark for engineered vision. With hearing and echolocation thanks to 5 bat species, dolphins and orcas, our giant hybrid bat redefines acoustic sensing. It doesn't just navigate the night, it paints it in ultrasonic detail. From micro-precision hunting to long-distance navigation, this sonar system transforms how our giant hybrid bat interacts with its world. By blending bat, dolphin, and orca DNA, we've created a living sonar LiDAR proof that nature's best blueprints, reimagined with gene editing, can leapfrog today. From hunting in dense woodlands to detecting environmental hazards and aiding search and rescue, this hyper-developed olfactory system transforms our hybrid into a living scent scanner. Imagine deploying these genes in aerial drones to map pollution plumes or locate survivors in disaster zones. Biological ingenuity meeting life-saving technology.